Hi guys, today we are going to be learning about finding the sum of a finite geometric sequence, and then later in the lesson we're going to learn how to find the sum of an infinite geometric sequence. So to start with, I'm going to give you the formula. The formula I'm going to write out in words instead of using symbols for it. To find the sum of a finite geometric sequence, we're going to do the first term of the given sequence. So we want to write of given sequence. Then you're going to multiply that by 1 minus r being your common ratio, to the number of terms in your sequence that you're finding the sum of, over 1 minus r. So we're going to fill in whatever our first term of the given sequence is. We're going to do 1 minus r to the number of terms, all over 1 minus r. You can use your calculator to help you through the calculations, plug things in the appropriate place, and you will get the sum of that geometric sequence. So n here representing our number of terms for that sequence. So let's go through and try a few examples. So here I'm looking to find the sum of this sequence. First of all, I want to confirm for myself that this is geometric. I have a number being raised to a power, so I feel confident that this is a geometric sequence. In this particular case, for this sequence, my first term is going to happen when I plug 0 in for n. So my first term is going to be 4 times 0.3 to the 0. So that represents my first term. Then I'm going to do 1 minus r. I know my value of r is my number being raised to the power, so it's going to be 0.3. And then the number I fill in up here for my exponent is the number of terms that I'm trying to find the sum of. If I'm starting at 0 and going all the way to 12, I know that I'm finding the sum of 13 terms. And then this is divided by 1 minus r again, so 1 minus 0.3. If I write up my little formula here, I've got first term times 1 minus r to the number of terms, should have written this first, over 1 minus r. So I'm going to fill in that information. So I'm going to do out my work. I have 4 times 0.3 to the 0. So if I do that out, that's going to be 4 times 1, because I know 0.3 to the 0 is 1. And then this stuff right here, I'm just going to leave in this format for now, 1 minus 0.3 to the 13 over 1 minus 0.3. I wanted to clean the stuff up in front of it, but at this point, I'm going to type this into my calculator, and I'm going to write down the answer. So I'm doing 4 times, I'm putting in my parentheses, I'm typing in the fraction. Remember, to type a fraction on your calculator, you do alpha, good Lord, y equals, and hit enter. It'll give you a fraction. I'm going to type in the 1 minus 0.3 raised to the 13th power. In the bottom of the fraction, I'm typing in the 1 minus 0.3. That way I don't have to worry about all my parentheses and all that fun stuff. And it tells me here when I do this out that my sum was 5.71. So I was able to quickly find the sum of that geometric sequence. Here's my example of my next geometric sequence. Once again, I know I'm geometric because I have a number being raised to a power. And in this case, my sequence starts at 1 and ends at 10. So once again, it's finite. So I'm going to do my first term times 1 minus r to the number of terms over 1 minus r. So my first term, in this particular case, I'm going to plug 1 in for I. So I'm going to have 2 times 0.25 to the 1 minus 1. Then I'm going to have 1 minus, my r value is 0.25. My number of terms, I'm going from 1 to 10, so that means there are 10 terms, all over 1 minus 0.25, so 1 minus r. Now I'm going to clean up this stuff in front here. This becomes 2 times 1, or 2. And then in my parentheses, I have 1 minus 0.25 to the 10th. Oops. You can leave those or not leave them, it doesn't matter. and then 1 minus 0.25. So big parenthesis at the end there. So if I type this into my calculator, once again, I'm just using the alpha y equals to type in my fraction to make my life a little bit easier. And I do that out, and I get my sum here is 2.667. It doesn't go on forever. It does eventually round to a different number. So I'm just going to go out 3 decimal places. And in this case, I have my sum of that finite geometric sequence. Okay, next, we're going to learn how to find the sum of an infinite geometric series, or sometimes we just refer to that as a geometric series. So a couple of things to notice here. If you guys look at this formula, if I were to write this out in words, we're talking about our first term, we're talking about 1 minus r to the number of terms over 1 minus r. This formula is essentially what we were just doing, only we wrote our formula in words before. I have a couple reasons for it, but I promise you the way I'm doing it is easier with you guys. What they're telling you here is a couple of really key things. One, in this little paragraph up here, they tell us that r, the absolute value of r, meaning we're just going to look at r as a positive number. Don't worry about whether it's negative or not. We need it to be less than 1. So we need r in order to be able to find an infinite series. We need this to be some fractional value. If r is some number like 2, or r is some number like 5 halves, which we think looks like a fraction but is really 2.5, we will not be able to find the sum of an infinite series. It will just get bigger and bigger and bigger. R has to be some fraction smaller than 1. So basically it needs to be between 0 and 1. And if that happens, then I'm going to be able to find the sum of the sequence. The other thing that's pointed out here is if we take this formula, which we had earlier in words and now we've written in symbols, if r right here is some fraction, like 1/2, and I'm raising it to some giant number like infinity, 1/2 raised to some giant number, if you even put 1/2 to the 500 on your calculator, you're going to see that the calculator spits back a 0 at you. So if we take that fraction and we raise it to a giant number, it's actually going to turn into a 0 and go away. That's where this formula right here is coming from. So we're going to take that formula right there and we're going to put it in words. And that's the formula we're going to use when we go to do a geometric sum when it is infinite. So our formula we're going to use is going to be, once again, first term. And this time it's going to be over 1 minus r. This is the sum of an infinite geometric series. And sorry about that. That's the formula right there that we're going to use. So the sum of an infinite is going to give us this right here. I know there was a lot of explanation on that last slide as to where that formula came from, but the key here is for you guys to know that in the end, the formula is simply the first term over 1 minus r. But we've made a note that this formula will only work, well, in this case, this is saying when r is greater than or equal to 1, I will not have a sum. So this formula will only work when r is less than 1. So here are a couple of examples when we're looking to find, in this case, an infinite geometric series. So when we're doing infinite, we're just going to do first term, and that means the first term in our particular series divided by 1 minus r. So in this case, our first term is going to be plugging 0 in for n. So we're going to have 4 times 0.6 to the 0 over 1 minus r, which in this case is 0.6. So one of the things to know about this, and this one is written with decimals, so we will often come up with a decimal answer, but this is actually not a hard problem to do in our heads or on paper by hand. We have the top is 4 times 1, which gives us 4, In the bottom is 1 minus 0.6, which works out to 0.4. Doing 4 divided by 0.4 is actually not a super difficult problem. The answer to that is just 10. And if you're having trouble doing that in your head, what you can do is you can move your decimal place on the top 1 point and on the bottom 1 point, and this becomes 40 divided by 4, which many of you would find much easier to do in your head to come up with that answer of 10 for our sum there. In the second one, we're going to use that exact same formula again. We're going to do the first term divided by 1 minus r. So the first term in this case, I don't have to do any work to figure out. It's right here in the problem. It is a 3, so I just fill that in. The r value, on the other hand, I have to do some work to do. My value of r, to find my r, I'm going to do my second term divided by my first term. So I have 0.3 divided by 3. And you guessed it, is 3 divided by 30, if I play with that a little bit, which is 1/10. So now my r value is 1/10. So I have 1 minus 1/10. And I can do out a little bit of work. This is 3 over. If I come up with a common denominator, I have that for my denominator. Keep working. I end up with 3 over 9/10, which we all know is 3 times 10/9. We quote, copy, switch, flip, and we do some canceling here, and we find out that our sum in this particular case is 10/3. We're looking for exact values for these sums, so you can't be afraid to play around with the decimals and turn some things into fractions. So this is our last slide for today. These two problems right here are just like the two problems you saw on the previous slide. So what I'm going to ask you guys to do is I'm going to ask you to pause the video really quickly. So just take a minute to pause it. I want you to do the first problem, do the second problem, then unpause it and watch me do the worked out solution. I'm not going to talk you through it. I'm just going to write it out. Now that we are done with all of those examples, I would like you guys to work on your homework assignment for tonight, which is 8.3 practice number 2. And it is already in OneNote and distributed to you. I believe the title of it is 5/1-8.3 practice number 2. I distributed it yesterday so that it would be there and ready for you guys to go. I will be back tomorrow. The expectation is that that assignment is done. If you didn't finish the homework assignment from Tuesday night, make sure that that one is done. We will, on Thursday, be going over any questions that you guys might have from both of those assignments, and we will be doing review for quiz on both of these sections that we've covered this week, 8.2 and 8.3. That quiz will be on Friday of this week. So make sure you guys are doing the work. Feel free to come see me during activity if you have questions on Thursday, or during class if you have questions as well.